Everyone, thanks for joining us today. We're gonna go through a test setup using time data acquisition in the new Neo interface. So I'm gonna dive into that. Here we are in the software. When I open up Neo, I'm gonna have this interface here where I can click on different squares to take me to different pages of the setup. Similar to how you would open up Microsoft Word, Excel, or PowerPoint, you would have the ability to open a project and dive right into it. So I opened up a blank project and I'm going to go to my channel setup. So I have basically 3 channels turned on. I've got a Tacho signal coming in. It's an analog TAC. And then I also have a data point that's an analog voltage coming in. And then I have a microphone plugged in. I can read in TEDs. So when I did that, I've got the calibration for the microphone I'm using. And then I just stay here in this channel setup and I can give the names as well. So if I click here, I can say that this is, we'll just call this accelerometer. And I can change the width of these tabs. We got a microphone. And then we have, we'll call this a playback tag. Okay. I can set up my sample rate for my test right here per channel. There's low and high data rate. If I want to use this microphone at a higher data rate, I can click and say, I want this high. And then that takes that up to the higher sample rate. If I want to change the sample rates, I can do that here as well. Okay. So all of that's right here on the channel setup. When I then stay in the main instrumentation tab, I can go to my Tacho setup. And this is where it gets nice. I'm going to select that Tacho 1. I'm going to arm it. And I'll be able to see those pulses come in live. I'm going to set the limits free and let that come through. And it's doing an automatic calculation of my Tacho. Now I actually have a 2 pulse per rev Tacho, so I'm going to deselect that so I can change that. Disarm. And then I can make this a 2. For 2 pulses per rev, rearm, see that new calculation coming in based on those pulses when I select that channel. So now I can see this RPM range that I'm going through. I'm going to disarm again. If I wanted to set anything else up, I can go to ranging, where I could set the voltage range for my microphone or accelerometer. I could also do my CAN setup. Or I could set any virtual channels if I want to do, say, like a vector sum or any kind of math on the channel to get the time data associated with that. So I can set all of that up here as well. Once I've got my channel setup done, I could do calibration. If I had a microphone calibrator, I could do that here. I could calibrate live. I'm going to go back to measure, and I'm going to highlight a couple of things here. This control parameters is what allows me to set up how I'm going to take my test. We are going to track on the Tacho, so my trigger type is going to be channel. Under channel, I'm going to pick my Tacho, and then I'm going to say the start trigger level is 2500. We're going to do a slope up, and then the stop trigger is again going to be channel on the Tacho, and we'll do a stop trigger level of 6000. So we have our Tacho settings there. If I wanted to do it based on time, I could set that up. Again, I would just say start trigger type based on manual, and I could set it to be time, and then I have it. So that's how we're going to track it. The next thing we're going to set up is our monitoring. When I want to look at the data, you can see there's this monitoring section. I can move this out of the way for now to gain that real estate. And now looking at monitoring, we did those 2 channel groups. We went higher for the microphone. So if I want to monitor that, I can turn on the spectrum map and maybe a spectrum average. Okay. And then if I want to monitor this one, I can turn on the same things. So this is going to be that analog accelerometer auto power. And then if I highlight this, it switches to the microphone. All right. So we'll be able to monitor our channels real time. And then we'll also be able to process data. To process data, we're going to set up a process that I can make here using this method library. And for this webinar, I've actually made one, so I can come in here and say open. I'm going to click this user-based process. I'm going to say okay. It's going to show that process. And then if I want to make any changes, maybe for the spectrum average, I'm going to change that to 1 Hertz resolution. I'm going to say close, and then I'm going to save as. I'm going to overwrite it and say okay. And I'm going to say yes. We're going to use this process during our test. So I'm going to go back to measure, and in my control parameters, I'm going to come in here to processing. I'm going to select the process name, the one we just made. And then I'm going to say automatically process after measurement and auto accept. So now when I come through here, it's going to process based on the channel. So it's going to do Tacho 1. It's going to do that same range that we selected for the viewing, and we're going to be all set to go. All right. Now when I go back to measure, I'm going to make some real estate for our displays. I'm going to arm. And we've got real live spectrum of our accelerometer going on, live color maps, live time. If I want to look at some auto powers here and here, now we've got the waterfall of the microphone and the accelerometer and those spectrums as well. Here, I'm just clicking on what we call a pivot table view to look at that data. And we'll talk about the pivot table view a little bit more in a couple of minutes after we take some data. All right, so I'm going to hit start. And you can see it's waiting for that release trigger. It's going to wait for that RPM to come up through 2500. And so it is measuring the run. It saw 2500 and now it's waiting for it to come back up. You can see these color maps. Right now it's just giving me a 4 to 5 second view. If I want to change that, I could go to my control parameters, and when I disarm, I can look at that online monitoring history size. I could make this a longer segment if I want. And as soon as we hit 6,000, we have that data. If I go to run 1, we have this spectrum map average based on our processing. If I highlight that, it populates the pivot table, and I can look at the data I have. So if I want to look for that accelerometer, I can look at all 5 function types. So I've got my max and min based on the statistic method that we've programmed. I've got the second order that we cut, as well as the stationary average and the tracked waterfall based on that RPM from 2400 to 5500. If I do limits free, it triggered just below 2500 like we told it to. So pretty straightforward. I got the data. Everything is available to me in Testlab Time Data Acquisition Neo. So I'm going to stop there and say thank you so much for joining us. Hopefully you give Neo a try. Thank you for joining us today.